Okay, gang, let's get started. Good morning, welcome back. So I'm a little bit sick today. Not going to be projecting very much. This is about the level you're going to get for the rest of the day. Take a look at our calendar. In theory, we're supposed to do 19 and start 20. Turns out 19 is really long. We're going to change the calendar. We're just doing 19 today. We'll do 20 and 21 next time. So, did I just get rid of everything? Just 19. Yeah, the homework due dates are still correct for what's on there. So class number 19 is what we're doing today. You'll see that there's no meeting this coming Thursday. Why not? Advising day. So meet your advisor and get registered for the fall and or summer. But there are no day classes this coming Thursday. The next time we meet will be a week from today, which is when we will review and take quest number 3. You can see over here, quest number 3 is on lessons 14 through 18. Remember, today we're doing 19, which means the stuff that we're doing today, which is going to be tough, not on the quest. And 14 through 18 only on the quest. Any questions on the calendar?
So we have a quest on Tuesday. Okay.
Yeah, the very next class is our quest, Tuesday. Other questions? Okay, so here we are on 151. In this lesson, we factor out the GCF, greatest common factor. And we begin factoring trinomials. Just a heads up, this demo is long. We're going to get through it as quickly as we can. Let's give this a shot. All right, first thing here is to multiply. So we know we're supposed to distribute there. 21x squared minus 15x. It's okay. 151. Okay, and then we see this brand new word for the first time this semester, factor. Factor means turn into multiplication. Turn into multiplication. So for example, I said factor 35. You tell me what times what is 35? 7 times 5 or 5 times 7, right? You took the number 35 and you turned it into multiplication. So you've seen the word factor before for numbers. We're going to be factoring things with variables in it, but it still means turn into multiplication. So 21x squared minus 15x is currently a subtraction problem. It's true there's a 21 times, right? That's a little multiplication there, and 15 times, but at its heart, this is the subtraction of two things, right? And we want to turn that into multiplication. And the way we turn it into multiplication is to recognize, hey, it actually was multiplication in the original form. You guys all agree this is equal to 3x times 7x minus 5, right? That's what we did over there. And what is the main operation in this red thing? It is multiplication. And it's true in the parentheses there's a subtract. But the parentheses is really just kind of one thing, right? So don't look inside the parentheses too closely. This at its heart is a multiplication, right? And so what we have done is factored 21x squared minus 15x. Multiplying, distributing is easy. Factoring turns out to be pretty darn difficult, and so that's what we're going to be working on today. You'll have to take my word for it for right now that factoring is something that's useful to us. We're actually not going to use the factoring that we're doing for a few classes, but we will get to a place very soon where we'll see that factored form is useful for us. Okay, so let's first do another multiplication. It says multiply 4x squared y cubed by all of this stuff. And we'll remind ourselves of how to use the box. We introduced this last class. So you can see the 4x squared y cubed is out on the left-hand side, and then the other three terms are across the top. And then remember, inside the box, you just write the area of each rectangle. So 4x squared y cubed times negative 3y squared, negative 12, x to what power? Second, y to what power? Fifth, right? We're multiplying y cubed, y squared, and we know we just add those powers. Okay, and then in the next box, we're doing this length times that width. So just multiply those two things and put it in the middle box here. negative 28x to the 4, y to the, y to the third, right? And then the last box is this guy times this guy. So what do we get there?
Would it be x to the third or x to the second?
In this last one?
Yeah.
X to the third, because we're multiplying x times x squared, and you add those powers. What's in front of the x to the third? 8. And y to the 4. And I'm going to try to remember to put what in front of the 8 here? A plus sign. I know you don't need it, but I'll just always put either a plus or a minus. Okay, so what have we just discovered? We've discovered that if you multiply 4x squared by negative, by all that stuff, by distributing, which is exactly what the box did for us, you get the things in the box. 3 terms all written down with minus signs and plus signs, okay? So that's the review of the box from last time. Now we're going to go in the harder direction. Suppose that I give you this, and I say, can you figure out how to write it this way? Can you pull as much as possible out of 1, 2, all 3 terms? Turns out as much as possible is this 4x squared y cubed. That's the thing that's common in all 3 of them, right? But we're going to pretend that we don't know that this guy over here came from 4x squared y cubed times a bunch of stuff. So we're going to build this thing from scratch, factoring this guy. Obviously, this is the final answer that we're going for. Okay, so some lucky folks in this room might be able to look at that and figure out just by inspection what the greatest common factor is. You can look at the 12 and the 28 and the 8, pull out the biggest number. You can look at x squared, x to the 4th, x to the 3rd, figure out how many x's you can take out of all of them. And the same thing with the y's. I'm going to show you a method that that will work no matter where you are in this class. But if you can do this process without the details we're about to do, that's okay. Yeah, Teresa.
So essentially what we're doing is we're factoring out
Yes.
that problem.
Factoring out. What factoring is the word I would use.
Okay.
And in this case, we're going to be factoring out that greatest common factor. But at the moment, we don't know that this is the greatest common factor. Okay, so here we go. Again, starting with this guy right here. I'm going to put like little star things around the additions and subtractions, just so we can really see the separation of our 3 terms. So I'd encourage you to do that too, just so you can really tell where the 3 terms are separated. Okay, so let's look at the number piece for each of the 3 terms. I've got a negative 12, I got a 28, and I've got an 8. And we're looking for the biggest number that goes into all of them. Negative 12, 28, and 8. What's the biggest number that goes into all? Is 4. And so we are going to rewrite negative 12 as 4 times something. 4 times negative 3. It's right there. Okay? And we're going to rewrite that 28 as 4 times what? 4 times 7. That is there. And we're going to rewrite the 8 as 4 times 2. That is there. Okay? So this is all written out for us here, but this is the process. And then the other thing we're going to do is we're going to like literally list out all of the x's and y's. So this x squared right here is written xx. And right next to it is y to the 5th. And you can see I typed out 5 y's all multiplied together. Seems like a bit laborious, but like I said, it's kind of a fail-safe way to be able to do this. I'm going to, again, put the little squiggles around the addition sign and the subtraction sign. I think you should too. So we still have our 3 terms separated just like that. Okay, and here is what we are going to do. We're going to look at the 3 terms and we are going to circle everything that's in common in all 3 terms. Now clearly they all have what number in the front? 4. We built it to put a 4 there. So go ahead and circle all 3 of those 4s. And now we're going to circle some x's. The first term has how many x's? 2. Second term has how many? 4. And the last one has 3. You want to grab as many as you can, but you can only grab what's there. So how many can you grab that they all have, like at bare minimum? They all have 2. right? And so we're going to circle 2 of these x's there and there and there. And in this middle term, the middle term has another x. It's actually got 2 extra x's left over. Why can't I grab another x? Yeah. This first term has run out. You have grabbed as many x's as you can from all 3 terms. Okay, play the same game with the y's. 5 y's, 3 y's, 4 y's. Circle as many as you can that they all have in common. How many is it? 3 is good. So 3 y's from the first one. All 3 y's from the second one, and then 3 y's from the third one. Okay. And it turns out we're actually pretty close to being able to write our factored version, our factored answer here. In the first term, that is the thing before this squiggly purple subtraction sign, there's a 4, there's x squared, there's y cubed, right? That's what we circled. What did we circle in between the purples? 4, x squared, y cubed. What did we circle after the last purple? 4, x squared, y cubed. Of course, it's the same thing. We circled the same thing in all 3 terms. That thing that we circled is the greatest common factor, 4, x squared, y cubed. Go ahead and write it right there. 4x squared y cubed. That is the greatest common factor by virtue of being the thing that we circled all 3 times. And in terms of what we put in the parentheses now, we're factoring out that greatest common factor. It's just the stuff that was left over, the stuff we didn't circle. So what didn't we circle before the first purple? There's y squared and also the negative 3. So negative 3 y squared right there. Then I'm going to write down the thing that was circled in purple here. It is an important subtraction sign. What's between the purples that we did not circle? 7 x squared, and that's it. And then again in purple, I'm going to write what? That plus sign, that circled plus sign, squiggly plus sign. And then finally, whatever we didn't circle after that purple, 2x, y. So everything that got circled repeatedly is the greatest common factor. That's the thing that they all have in common, so it's out front. And anything that didn't get circled is what's left over. It's inside the parentheses. How does this final answer right here, this whole thing, how does this compare to what we came up with that box up above? Isn't that it right there? Yeah. Okay, so it's a process. I'm hoping it's a process that makes sense, at least with a little bit more practice. It will start to make sense. Like I don't want it to just be memorized because it's silly to just memorize processes that are meaningless, but I'm hoping it makes sense. Okay, like I said, some lucky folks will be able to do all this kind of without writing out all the circles and things like that. So I will show you the kind of shortcut way. I'm not going to force you to do the long way if you can do the shortcut way. Here's the stuff written out in the box. Again, trying to factor. Look at the we're looking at all 3 terms and trying to factor out the greatest common factor. Doing the same problem a third time here. What number goes into negative 12, negative 28, and 8? 4. So we're going to put a 4 out there. We're going to look at the x's, and we're going to pull out as many as we can, but only what they all have in common. X squared, x to the 4th, x to the 3rd. What's the most you can take out of all of them? X squared. And so you start to develop the shortcut that's like, we're just looking for the smallest power of x, right? That's what they all have in common. And how about the y's? What's the most y's you can take out of all 3? Y to the 3rd. Okay, and then from there, we're going to start filling in the stuff at the top. I know that whatever is up here at the top, right now it's blank, but whatever's up there is going to multiply by this 4x squared y cubed and get negative 12x squared y to the fifth, right? That's how the box works. You multiply the two things outside and you put it inside. Okay, so it's just a matter of thinking backwards from multiplication. What can I put at the top to multiply by that 4 to get the negative 12? It's negative 3. Let's focus on the x's. How many x's do I need up here so that when I multiply by the x squared in blue, I get the x squared in black? We don't need any. We've already got all of the x squareds we need. Y to what power multiplied by y to the third will give y to the fifth? Y to the second. That's it. Y. Okay, let's move over to the middle here. 4 times what for negative 28? Negative 7. X squared times what for x to the fourth? X to the second. Y to the third times what? What is it? I'm still in this middle guy. How many more y's do we need? We don't need any more y's. We got them all taken care of. And then finally, 4 times what for the 8? It is 2. What else should we put? But before the xy, what else should we put? Plus, right? Plus 2. And then how many x's do we need? 1. Y to the third to y to the fourth means we need 1y. And so this technique is like a fill in what's missing, right? You know what you're trying to build. You have part of it in front in blue here, and you just fill in what's missing. And then looking at this answer, again, hopefully we can say, hey, we've got this thing in the front. And then it distributes into everything that we've written outside the box there. And of course, it's the same thing that we got when we did it, that kind of long drawn out way. So you got two options for this factoring out the greatest common factor. Do whatever's comfortable. If you're not comfortable with this sort of super short, efficient way, then take your time, do the circling everything way, and eventually that'll become easier and you might feel like you can move here, but you never need to move to this one. You don't want to. It's up to you. Any questions on this? Okay, next page. All right, so everything that we just did is kind of written out there. We're jumping to number, well, we're gonna just do vocabulary here in 7 and then we'll do 8. So it says one more time, the process of turning addition and or subtraction into multiplication is called factoring. And we'll just reiterate, this original problem was a subtraction and addition. The new version of that same thing is a multiplication, right, at its heart. Even though in the parentheses there's still a subtraction and an addition, fundamentally the right-hand side is multiplication. That's why we call it factored form. Okay, there are going to be a number of different factoring techniques that we use this semester. We'll be seeing them over the next few weeks. Again, the goal for all of them is to turn addition and subtraction into multiplication. This specific kind of factoring we just did is called factoring out the GCF, factoring out the greatest common factor. Okay, so here's one that is tougher. We're going to factor negative 2x cubed plus 8x squared plus 24x. Doesn't seem like it should be tougher. In fact, it looks easier than the one that we just did. There's no y's. And the first step is easier. Let's give it a shot. We'll do the super efficient way here. What number goes into 2 and 8 and 24? 2. Look at all 3 of the x's. What's the most you can take out that they all have in common? Just a single x. See if you can fill in those 3 blanks up at the top, all 3 arrows. If you're stumped, check in with the neighbor. Are you with us here? Okay, let's see how we did here. What goes on the top here? Negative x squared is good. Next one. 4x, we're missing something. In front of the 4. Plus, gotta have a plus. And then here, plus 12 is good. Okay, so that part is easier than the one that we just did. And so what we've established here is that this original thing, that's what we started with, is equal to, we pulled the 2x out in the front, and we wrote down what's up in red up at the top there. So far, so good. In this thing that I'm going to color yellow, there's nothing else that you can pull out of all three terms. We have factored out the greatest thing that we could possibly factor out. And so this negative x squared and the 4x and the 12 don't have anything in common left over. So there's a different kind of factoring we're going to do here, and it's much tougher. We are going to be using a 2x2 box to factor that thing in yellow. Before we do, let's remind ourselves of how to multiply using the 2x2 box. So we're going to multiply here. Negative 3x minus 4 times 2x plus 5. Let's go ahead and put the first guys out in the front. Negative 3x minus 4. And up on top, 2x plus 5. And then remember, in every one of the little rectangles, we put its area. Top left, 2x times 3x, 6x squared. Your neighbors, can you fill in the other three boxes, please? 6x squared, yeah. And then the top right is what? 15x is good. I'm still going to want to put something in the front. Plus. Bottom left. Bottom right. Good. And so that means that we can say that if we multiply both of these guys together, we just get all the things in the red. And then remember, one nice thing about the box is that if you line things up, then the like terms are always on a diagonal. So in this case, these are the like terms right here, right? 15x and negative 8x. And so when we smush those together, we get 6x squared plus 7x minus 20. Good? Okay. All right, so multiplying with the 2x2 box is pretty easy. We're trying to do the hard direction now. Somebody has taken two binomials, there's one and there's another, and multiplied through with the box and got 6x squared plus 7x minus 20. One of the reasons that this is going to be hard is that where did the 7x come from? It came from the 15x and the minus 8x. But we don't know that, right? We don't have that information unless we've just done this problem. Well, we do know it because we just happen to do this multiplication. But if I don't tell you, if I don't tell you this, and I just say, hey, I multiplied two things together and I got 6x squared plus 7x minus 20, you can't know that 7x came from 15x minus 8x. Could have come from, 10x minus 3x. Could have come from anything. And so the 7x contains information, there's information in there that was lost. And so it's hard for us to recover it, but we'll be able to. Two facts about the box. Tell me what you get when you multiply this diagonal right here. 6x squared times negative 20. What is it? Negative 120x squared. Everyone agree? Negative 120x squared. Okay. So far, so good. Now what I want you to do is multiply these two guys. It's a little bit tougher if we don't know our 15s, but 15x times negative 8x. Negative 120x squared. This should be a surprise. First time I saw it, it was a surprise. I had been teaching for many years, and I did not know this. That's what I heard in my head. But it turns out it's always true that if we multiply binomial times binomial, and the product on the one diagonal and the product on the other diagonal, always, always, always the same. We're going to take advantage of that. The other fact, if you add the two things on this diagonal, what do you get? You get the 7x, right? Isn't that exactly how we came up with 7x? So right here, the sum is equal to 7x, right? Put a positive 7x there. Okay, so two facts. Both of the facts that I'm interested in are actually going to be the ones on this diagonal right here. That's what we're going to be focusing on. But the facts about that diagonal are that the product is negative 120x squared and the sum is 7x. Agree? And here's the idea. That negative 120x squared, I know we did 6x squared minus 20, right? Isn't that right here? 6x squared and minus 20. So if I just, again, we're imagining I'm just giving you this, and I'm asking you to go the hard direction going backwards. I'm only giving you that information. Well, I'm giving you enough to multiply this diagonal, right? And I'm also telling you that 7x is the sum of this diagonal, right? All right, let's see if we can put it together. Yes?
That was negative, the product is equal to negative 20x squared.
120x squared. Yeah. Okay. All right, here we go. All right, so starting to put ourselves in a position to do the hard direction here. Again, I'm going to give you this thing and give you the answer. Say somebody multiplied two things together and got that answer. The 6x squared, where should we put it? Where was it in the box that we just filled in? Was the top left, right? So let's put it there, top left. And that 7x, wasn't that the sum of these two things? Okay, I don't know what the two things are yet. I mean, we know, right? It's 15x and negative, what was it? 7x. But we got to pretend we don't know. But we do know for sure that when we add up these two blank boxes, you're going to get 7x. And how about the minus, yeah, positive 7x. How about the minus 20? Where was that in the box? Was the bottom right? And then as soon as I know that that's in the bottom right, we can write the product of the two diagonals that we have here, the two terms on this diagonal, and that's the negative 120x squared, right? And so armed with very little information, all we had was 6x squared plus 7x minus 20. We have established for sure that the two things in the empty boxes, that's the hard part, they for sure multiplied to negative 120x squared, and they for sure add to 7x. And it turns out that is a problem that we can solve. So let's do it for one that we don't know the answer. We already know the answer here. It's 15x and negative 7x. Let's do the one that we were working on before. Okay, so I will highlight in yellow this thing right here. That is what we are trying to factor. Parts of these things are written out here. I'm just gonna, what am I gonna do? I don't really have another blank box that I can work from. You know what? Let's do this. Right here. Can you guys go to this on the next page? 22. Can somebody remind me, what was the thing we just highlighted? Negative x squared. Thank you. Okay, so we've got this box with lots of numbers in it. It might look intimidating initially. It's supposed to help us keep all of our information organized. Okay, the goal is to figure out what we can multiply to get this negative 7x plus 4x plus 12. So I'm just going to put it's equal to the product of two binomials. There's lots of foiling or distributing that happened, and we're going to undo that. We're going to factor. So filling in the goal is the final, filling in the parentheses is the final goal. Okay, negative x squared. Where does it go in the box? Top left. Negative x squared. How about that 4x? Is it in the box or is it out of the box? It's out of the box. What is it? It's the sum Include that plus sign, please. Plus 4x is the sum. Next up is the plus 12. Where's that go? That's the bottom right. Again, include the plus sign. See the little numbers that are floating around this blank box that we're filling in? Which ones did we just fill in? 1, 2, and 3. I put those blank numbers to kind of help us follow the same process every time. 1, 2, and 3. I'm giving you 3 terms. Negative x squared plus 4x plus 12. 1, 2, and 3. They always go in those spots, in the box and outside the box. Okay, next up, number 4. Yeah, Teresa.
Why is there like 1, 5, 5,
Yeah, it's the order we're filling these things in.
Okay.
So the next up I see, we did 1, 2, and 3. Now we're doing number 4, which is the product. The product of the only diagonal we have. We just multiply. What is it? Negative 12 x squared. Okay, so here is the hardest part coming up right now. You can see that the next place we're going to go is the 5s. 2 things, both labeled 5. They're both happening at the same time. Here's what I know about the 2 things in the blanks in the box. They add up to 4x, and I multiply to negative 12x squared. Don't forget, negative 12x squared was the product of the things that I do know. But remember, the product on the one side is always equal to the product on the other. So even though I don't directly know what those 2 blanks are, I know for sure they multiply to the same thing that the one diagonal multiplies to. Okay, so we are looking for 2 things that multiply to negative 12x squared and add up to 4x. Some of you might already know what those 2 things are, and that's great. But there's a mechanical process that we can follow. It is pretty straightforward once you've done it a few times. Let me ask you this. How many things add up to 4? How many different pairs of nice numbers add up to 4? Like 1 and 3, right? 2 and 2. Is that it? 4 and 0. Okay, that's it, right? Nothing else adds up to 4? How about 5 and negative 1? 6 and negative 2? Okay, there's infinitely many things that add up to 4. Okay, so we don't want to start by focusing our attention on that sum because there's infinitely many things that add up to 4. But if I ask you how many nice things multiply and give you negative 12, that is a pretty short list, right? 1 times negative 12, 2 times negative 6, 3 times negative 4. And then I think actually there's like the slight differences with the signs. 4 times negative 3 is not the same as 3 times negative 4. And then 6 times negative 2, and then 12 times negative 1. Is there any other nice pair of numbers that multiply to negative 12? The answer is no, not unless we start getting into fractions. Like 7 does not go evenly into negative 12, right? So we focus our attention not on the first thing you see, which is sum, but on the second thing you see, because the things that multiply to 12 is pretty small. So we're just going to list them. Here we go. Don't quite have enough room. I don't know. All right, we'll just go right here. Okay, so looking for things whose product is negative 12x squared. Okay, I always start the same thing. 1, and then whatever else. 1 times what? Negative 12. Let's pause for 1 second. If you multiply those, do you get negative 12x squared? You do not. You get negative 12. We need to make it so that it's still x squared. Okay, well, you got 2 choices. You can put x squared there, or what's the other possibility? Put an x squared on this one, or an x squared on this one, or what on each? Or a single x on each one, right? We know that things on this diagonal have a single x on them, right? You remember 15x and negative 7x? So just as a rule, as soon as you put your numbers down, you just tack on a single x on each of them every time. Okay, so that was 1 going into negative 12. Next up is 2. How many times does 2 go into negative 12? Not quite 6, but negative 6. Really important that we get the signs right. Negative 12x squared there. Don't forget x on each of them. Okay, next one is 3. Go ahead and write it down. And I think you're going to go into the next, there's some blank space below that line of text. So feel free to go straight down into that next blank space. 3 goes in how many times? -4. Again, x on each one. I want you guys to list. There's 3 more. 4 goes in, so write it down. 4, and then its partner. Careful with the signs, and give each one an x. Once you've got 4 written down, does 5 go in? I'm just going in order. 1, 2, 3, 4, 5. Does 5 go into -12? No, not evenly. Does 6 go into -12? Yes, it does. You put 6, and you put its partner. And I'm still going in order. 7 into -12? No. 8, 9, 10, 11, 12. That's the one. Okay, I know I went slower than you guys wanted to go there. If you're really comfortable with the numbers and you can skip right from 6 to 12, then so be it, right? I don't need you, I'm just giving you a process. What's that, Jeff? No, just one x on each. Yeah, that's always going to be the right thing. Okay, here are all of the possibilities for things that multiply to -12x squared. Remember, we had one other piece of info we haven't used. We want the sum to be 4x. You're just looking for the winner. There's one winner in there, one pair that adds up to 4x. If you can just zip and find it, then that's great. But even if you can't, again, I'm giving you a process. We can just methodically add them up. There's not that many, there's only 6. What do you get when you add up these two things here? 1x plus -12x. -11x. Fill them in. I know you already see which one is going to work, but just fill them in. It's only 6. Add them all up very carefully. Next one is 2x plus -6x. Try to remember to put plus signs on the ones that are positive. Okay, and again, we were looking for the one that added to 4x. Did we find it? Second one from the bottom. See it? Does not matter, but I'm going to ask you all to put them in the same spots. I'm going to put them just so that it all looks the same on the board. So 6x and -2x, they go up here in either order. I'll put the 6x up there and the -2x there. Copy that order just so that we can all have the same thing for the rest of this problem. But it makes no difference. You could put them in the other order, you'll get exactly the same answer at the end. Okay, there's a little bit of work left to do to fill in the stuff on the outside, but I just want to pause here for 1 second and say, I don't need to see you list methodically all of the different factors of -12x squared. I don't need to see the list of all the sums of all those factors. I just need you to get to the winner. However you get there is fine with me. If you start to list, and as you list them, you right away start writing the sum. As soon as you see this -4x, there's actually a shortcut to zip to the answer. -4x is not right. What was the answer? What should it have been? It should have been +4x. Well, if you get the right thing but the wrong sign, then it just means you had the right thing but the wrong sign. The right thing could have been a +6x and a -2x. So you don't need to go through all of them. And in fact, if this had been the very first one in our list and we saw +4x, we stop, right? You don't need to list them all. You just need to keep going until you find the winner. Okay, next up is to fill in the pieces on the outside of this box. So here we go. The next thing that I do is out here at number 6. I'm going to look in this first row and I'm going to factor out the greatest common factor. This is supposed to be pretty straightforward. there's an x in both of these guys, right? Is there an x squared in both of these guys? No. So x is the biggest thing that we can pull out there. I'm going to change this problem just slightly for a moment. Don't copy this down. But suppose that I put a 10 right there. What's the biggest number that you can pull out from the 10 and the 6? You can pull a 2 out. And if that were the case, don't write this. You put a 2 right there. That's as hard as it gets. You just look at the numbers and you pull out the greatest common factor of the two numbers. You look at the x's. It's almost certainly going to be a single x that you can pull out of both, and that's all. Say again? It would be 2x. Yeah. Okay. You are welcome. I put an x here. You're welcome to say, hey, I want to pull negative x out. That's okay. You'll get a different but equivalent answer. I'm just going to pull x out. Okay. The rest of this is just going to be like following following the pieces of a puzzle. I'm going to look next at number 7, right up here. Just thinking about the way that things multiply together. I know if I multiply these two things, I'm supposed to get negative x squared, right? So what has to be up there? Got to be negative x. So I'll put a negative x right up there. Next place I go is number 8 over there. And I'm just going to point and say whatever you put up here in number 8 is supposed to multiply by this x and give you the 6x there. So what's supposed to go up there? Something times x is 6x. Yeah, I didn't do such a great job of copying that plus sign there. Positive 6x. Okay, next up, we're looking, whatever goes in 9 is supposed to multiply by this thing up here at the top and give negative 2x. We see it? Is it 2 or negative 2? It's positive 2. Put a plus sign. Which one of the 4 things in the box didn't we look at just now? That 12, the bottom right, we didn't look at. Okay, well, you have no more freedom. You filled in everything outside the box. So this is a moment where we cross our fingers. If we did everything right, it's going to work. But you got to check. What 2 things are supposed to multiply to give the 12 in this case? The plus 2 and the plus 6. And does it? It does. If it didn't, you made a mistake. Go back and try to find it. But you got no more choices at that point. So you're just hoping that everything works out magically. And if you did everything right, it will. Yeah. Yeah, so if we had put, I'll put this up here and then I'll erase it. I'll put it in purple. If you had put a negative x here, that would have changed this to a positive x, this to a negative x, and this to a negative 2. Would have changed all of the other signs, which is equivalent, and it's a full credit answer. It looks different, but it's the same. Okay, so then our final answer here, let's just write it down. We started with, oh yeah, we're just putting it here in the black parentheses. We started with negative x squared plus 4x plus 12. You just have to read the things outside the box. I'll start on the left, x plus 2. And then read across the top, negative x plus 6. Okay, so I could have prefaced this by saying that this is one of the most complex procedures that we will follow this semester. Like, I recognize it's a lot of steps, but as with many things in life, with practice, it gets easier. Some of you have probably seen this kind of factoring before, where you take a trinomial, 3 terms, and you factor it into 2 binomials. And you might have some shortcuts in your brain that say, oh, I just need 2 things and multiply to 12 and add to 4, and you just plop them in there. I think it's good for as far as it gets you, but those shortcuts work in only very specific circumstances. And this box method works for all of them. So I'm not going to ever force you to use the box, but I will encourage you, even if you have some previous technique from another math class, to try the box for at least half of these activity problems, okay? All right, one announcement, and then you'll spend the rest of the time on the activities. Like I said earlier, we have our quest coming up next class, which is Tuesday, a week from today. The very first page of your packet, if you go back and look at it, what is it? The first page of the packet is that perfect powers table, and on the back are some really handy-dandy formulas. You are welcome to bring that sheet with you to the test. So bring your packet with you, and then you'll just rip it off and use it on the quest. Yeah, the chart. And all the nice formulas on the back. In addition to that page, you are also welcome to create your own one-page reference sheet. You can do that for every quest and test, but make sure you bring that page with you to the quest, okay? All right. In addition, yeah, so 2 pages. Okay, this is a good time to just stand up for a minute and stretch, and then jump in on the activities. Yes. Yes.
Oh, okay. I thought it was just the front.
No, front and back.